Hey everyone, and welcome to The Explainer. Today, we're diving into a topic that honestly touches almost all of our lives in one way or another. We're going to explore the incredibly complex, fascinating, and yeah, sometimes a little unsettling science of why we get hooked on things. You know, addiction is a word we throw around a lot, but what is actually happening inside our brains and our environments when a behavior crosses that invisible line from just a simple choice into an overpowering compulsion? Well, we're going to unpack the very latest scientific research today to find out exactly that.
So think about this for a second. We've all probably joked at some point about being addicted to our smartphones, right? But seriously, think about that mild panic that sets in when you pat your pocket and your phone isn't there. Or the way 2 hours just completely vanish when you're endlessly scrolling through social media. This right here raises a really crucial tension that researchers are actively wrestling with today. Where exactly is the boundary between a bad habit, a coping mechanism, and a clinical diagnosable addiction?
To answer that, here is our roadmap for today's explainer. We're going to start by defining the addiction spectrum. Take a look inside the addicted brain and explore the roles of learning and memory. Then we'll apply all of that to modern behavioral addictions. And finally, look at how science is measuring and treating these loops. Let's get started.
Okay, Section 1. Defining the addiction spectrum, moving beyond substances. Let's look at the foundational debate about what addiction actually is.
So, the traditional view, and this is heavily supported by institutions like the National Institute on Drug Abuse, is called the brain disease model of addiction, or BDMA. This model basically frames addiction as a chronic neurobiological disease. It argues that substance use fundamentally impairs the brain, which leads to automatic, uncontrollable behaviors. But on the flip side, you have the learning and behavioral model. These folks suggest that pathologizing addiction purely as a brain disease might actually hurt someone's psychological recovery. Instead, they see addiction as a deeply ingrained learned behavioral disorder tied to memory, habit, and environment. Now, we aren't here to pick sides in this academic debate today. Instead, we're going to draw on insights from both frameworks, because when you put them together, you get a much more complete picture of the whole shebang.
Let's move from that big picture debate down to the micro level. Section 2, Inside the Addicted Brain, the Neurology of Craving. A totally crucial framework for understanding this is the IRSA model, which was proposed by researchers Goldstein and Volkow. That stands for Impaired Response Inhibition and Salience Attribution. It sounds like a mouthful, but the core idea is actually pretty simple. Addiction dangerously scrambles your brain's priority system. Usually, our brains are fantastic at attributing salience or importance to things we literally need to survive, like food or social connection. But in an addicted brain, that salience gets completely hijacked. The substance or behavior suddenly becomes the absolute top priority, and the cognitive processes you need for self-control, motivation, and flexible attention get severely disrupted.
Neuroscientists often use a dual system model to explain this. System 1 is driven by the striatum and relies on dopamine, and it becomes hyperactive. Actually, if you look at Malick's 2020 work on computational models of addiction from his conceptualization workshop, we can view this through reinforcement learning. Dopamine acts as a reward prediction error. It is constantly updating the value of the addictive behavior until it overrides literally everything else. It's basically a stuck gas pedal. Meanwhile, System 2, your prefrontal cortex, becomes hypoactive. It loses its ability to hit the brakes on impulses and resist short-term rewards for long-term goals. So to put that in perspective, you're driving with a stuck gas pedal and failing brakes. Not a great combo.
But you might be wondering, why do some people develop these failing brakes while others don't? Well, it comes down to a developmental model of addiction. Addiction isn't just about a drug or a behavior in a vacuum. It actually starts with a person's genetic makeup, which sets the baseline for their neurobiology. But the crucial part is how that biology interacts with early attachment experiences. Things like how we bonded with caregivers, early trauma, and our general environment. Those early experiences literally shape our physical capacity for self-regulation. So when you combine a genetic vulnerability with environmental stress, you create the perfect storm for an addictive behavior to take root. Okay, so we've got the biological vulnerabilities down. Let's transition to the cognitive psychology side of things in Section 3, Learning, Memory, and Habits, the cognitive loop. Addiction doesn't just spontaneously happen to us. It's heavily reinforced through operant conditioning. And here's where it gets a bit dark. Beyond the initial positive reinforcement of a high, a much stronger driver takes over. Negative reinforcement. As addiction progresses, those computational models we mentioned earlier show that the brain's baseline actually shifts. It creates these states of deep withdrawal, anxiety, or stress. And the addictive behavior? It provides desperate, temporary relief from that exact pain. This creates a powerful, basically an inescapable behavioral selection loop. Your brain mathematically optimizes to learn that the absolute only way to feel normal or to escape distress is to repeat the behavior.
And as researchers Weirs and Stacy point out, as these loops repeat over and over, they form deeply ingrained implicit memories. What this means is that System 1, that computational gas pedal we talked about, learns to react completely automatically to environmental triggers. We're talking about things like seeing drug paraphernalia, walking into a casino, or even just feeling a spike in stress at work. These memories operate totally without conscious awareness. This is what explains the tragic reality of relapse. A person's conscious System 2 might desperately, truly want to stop, but their implicit System 1 memory automatically triggers an overwhelming craving before they even realize what's happening.
Now that we have this incredible scientific toolkit, we understand the gas pedal, the brakes, and the memory loops, let's zoom back out. Section 4, when behaviors become addictive, the modern dilemma.
So we are back to our smartphone question. Because the mechanisms of reward and learning are universal in the human brain, researchers argue that we can absolutely become addicted to behaviors, not just physical substances. But to keep us from running around calling every single bad habit an addiction, scientists like Matthias Brand use really rigorous meta-criteria for World Health Organization classifications. First, they look for severe functional impairment in daily life. Next, the behavior actually has to fit established addiction theories. And finally, there needs to be concrete empirical evidence, like neuroimaging or hard behavioral data, proving the underlying mechanisms are the exact same as substance abuse.
To do this, researchers use a really rigorous diagnostic decision tree. They start by asking if the behavior mirrors existing gaming disorder guidelines. Then they rigorously check for functional impairment. If the answer is no, it stopped right there, not a mental disorder. But if yes, they test it against those addiction theories and the underlying biological mechanisms. It is a very high bar, and it's intentionally designed that way, so we don't accidentally pathologize normal, everyday enthusiasm or just standard bad habits.
So you're probably wondering, what actually passes the test? Currently, gaming disorder and gambling disorder have officially crossed that threshold and are recognized in the ICD-11 as true medical disorders. But the scientific debate is absolutely raging around the others on this list. Problematic pornography use and buying shopping disorder are showing strong clinical evidence of sharing those cue-reactive and craving mechanisms. Problematic social network use is also under intense scrutiny right now, though, to be fair, the neurological evidence for that one is currently a bit more mixed.
This brings us to a really vital philosophical tightrope. On one hand, if we call someone who loves shopping or spends hours scrolling TikTok an addict, we risk over-pathologizing everyday life and totally watering down the term. But on the other hand, if we ignore the people who are bankrupting their families, losing their jobs, or destroying their relationships due to these digital and behavioral traps, we trivialize conditions that are genuinely, literally destroying lives. So if we know how the brain gets hijacked, and we know these behaviors are very real, how on earth do we fix the brakes? Let's move into our final section, measuring and treating addiction, rewiring the loop. Because addiction is so deeply tied to learning and memory, our treatments essentially have to reverse engineer those exact same cognitive loops. Behavioral treatments do this by using classical and operant conditioning. For instance, therapies might involve contingency management, where positive alternative behaviors are actively rewarded to replace the drug's reward. Or they use community reinforcement, which means changing the patient's environment so that natural, healthy rewards, think social connection, fulfilling work, become more valuable and accessible than the addictive behavior. You literally have to teach the brain a better way to find relief. And this is where mindfulness-based interventions, or MBIs, have shown some really incredible promise. Now, mindfulness isn't just about lighting a candle and relaxing. It is a clinical tool used to manually repair the brain's brakes. Remember how we said addiction is driven by that urgent, desperate need to avoid negative emotions? Well, MBIs specifically target that avoidance. They teach individuals how to sit with unpleasant experiences or cravings without automatically reacting to them. By doing this, they disrupt those automatic System 1 triggers and basically buy the brain enough time to re-engage System 2, that prefrontal cortex executive control. It's all about bringing conscious awareness back into an unconscious loop. Which leaves us with this final thought. We now know the neurobiology of how our brains attribute salience, how our memories automate our cravings, and how our environments reinforce our choices. But we also live in a modern world where algorithms, casinos, and digital platforms are intentionally engineered to trigger these exact same dopamine-driven learning loops. So I want to leave you with this question to ponder. In this environment, are you truly in control of your daily habits, or have they subtly started controlling you? Thank you so much for joining me for this explainer.
I really hope this deep dive into the science of addiction has given you a powerful new lens to understand human behavior. Keep asking questions and keep learning.